Okay, so let me introduce myself. I'm Michka Popoff. I'm a homebrew maintainer. You can obviously find me on GitHub and on Twitter. My current role is Python developer, and I'm also doing a little bit of DevOps, but it's unrelated to my open source work. I worked on maintaining different projects, mostly scientific packages. I was a homebrew science maintainer up to 2017. And then I joined the Linux Brew organization in 2017. So my talk will be in two parts. The first is about improved Linux support in Homebrew. So for the small historical part, Homebrew was created for 2009. That was for macOS. And then in 2012, Sean Jackman created Homebrew on Linux, which was then called Linux Brew. And Linux Brew was a fork of Homebrew. And then in 2017, Sean Jackman asked me 2 or 3 times to join the org. I refused first, but at the last time he asked, I said yes, and here I am. In 2019, we announced the official support for Linux in Homebrew. So we sort of merged both projects. So here is a picture of Mike Quaid, the project leader of the project, making the announcement at the FOSDEM conference that was for the release of Homebrew 2.0. But if you look at the release notes, you might think that everything was fine. But what did we actually do? We took the Linux specific code of the package manager, which was hosted at github.com/linuxbrew-core, and we migrated that code to the Homebrew organization and the Homebrew package manager. So this work took us around 1 year, and this brought a lot of stability for our users because we got rid of one of the forks. We also defined some common governance documents. We had the first general meeting. We merged the sponsorship pages and the finances because it didn't make sense to have that duplicated. We had common communication channels, and also we had a few beers at FOSDEM. And I think the logo was redesigned at that point. We still had a big issue, and this you might not have seen it in the release notes, is that we still had 2 core repositories. So when you were on Mac, you would get your packages from homebrew-core, and if you were on Linux, you would get them from linuxbrew-core. Linuxbrew-core being a fork of homebrew-core. The core repository is what we call the place where we store like the definition of the packages, or the formulae, how we call them. So before going into detail, let's take a small step back. How are formulae or sort of package definitions working in Homebrew? You have a list of Ruby files in homebrew-core. Here it's the Mac side. Let's take, for example, the hello package, which is a nice test package. You have the definition of the web page, the download link, the checksum of your source file. And then at the bottom of the file, you have the install steps, classical configure and make install steps. And then you have this bottle block, which defines the checksums of the bottles. Bottles are sort of containers or just tar files with pre-compiled binaries, and these will be then installed on your computer. So Homebrew installs mostly pre-compiled stuff. How can you or any user update a package for Homebrew on macOS? You have to open a pull request in homebrew-core. So that's the Mac side. So on the left side, you see the diff. Somebody tried to update hello from 2.9 to version 2.10. And then the pull request will trigger a package build, test, and the bottle upload on GitHub. And then once we merge the pull requests, it will create 2 commits, one with the change in the version, and then a second commit which will update the checksums. So now when you run brew update, you'll get the new package. Of course, as Linux Brew is a fork, there was some merge steps involved. So on the left side, you still see the Mac workflow I just described with the 2 commits on the master branch of homebrew-core. We had a command which was called brew merge homebrew, which was a Ruby script doing a lot of Git stuff. And then it would merge a few commits from one repository in the other. Of course, you had to solve merge conflicts. And then the Linux CI would then run and upload and build the Linux bottle. And then, of course, here is then the diff for the Linux bottle definition. There were other differences between the Linux and the Mac version of the formulae. So on the left side, like a small example, typical example of make targets where you have to input different targets based on the platform. You have different dependencies. On Mac, Homebrew uses system dependencies. On Linux, we try to ship as many packages as possible, so you don't have to pre-install them. There are Mac or Linux only fixes or patches. Obviously, like the extension dylib versus shared object extensions, yeah, there are a lot of like in replace and fixes for that, and then specific configuration options. Yeah, sadly, build scripts are often not really portable between macOS and Linux, and we have actually more workarounds for Mac than Linux. Why did we want to get rid of linuxbrew-core? And that's yeah, the thing we did at the end. The main pain point was that there was no Linux CI in homebrew-core, so the packages were built for macOS, but without testing. So when we did the merge, we ran the Linux CI, and then we realized that sort of after the fact that some package did not build anymore for Linux because for whatever reason, some macOS only changes broke the package build. So someone added some configuration option which was only for macOS, and the merge process did not pick that up. And then some packages took long to build. So for that delay of 3 to 4 hours, sometimes you would not have the binaries, and then Homebrew would start building that from source on your computer. So some days I felt like in the meme, actually this was not fine. Package build order was important. So we did not merge like 1 or 2 commits, but like 15 packages, that's like 30 commits. You had to wait between 20 to 60 minutes for the builds to go on, and then only then you could do the next merge. So yeah, you could go and drink a coffee in between. That's like a rough idea. For long-running builds or complex merges, we did only 1 package at once, which also delayed the merges. Yeah, if you look at the Git history of homebrew-core, you see that the packages are built like one after the other in serial fashion. So we had to do the same in linuxbrew-core. It was hard to automatize. We tried and we sort of failed because basically you need to solve merge conflicts, and yeah, it's hard to do by a machine. We as a team and also I did not scale. So I looked at the Git history from 2017 to 2021. There were more than 6,000 core merges, and I did 5,600 out of these. And that meant like 4 to 5 merges per day, which was a lot of work for the whole team and for me especially. One reason also was that the community added more and more packages, and they fixed the Linux packages. So when you start getting more users, they will fix more stuff. And then, yeah, we had like around 1,000 packages in 2018 for Linux. Now we have more than 4,000 working packages, which is actually really nice, but which meant that in 2017, out of 15 packages, maybe 2 or 3 built, because yeah, I didn't care about the broken ones. And then in 2021, yeah, all built. So this meant more time to fix stuff when there was a broken package. So we worked really hard, and what we did is another epic migration after the package manager. We migrated all the Linux brew-core code back from the fork to the main branch or main repository. It took us 2 years. I thought it would take us 6 months, but actually it took us 2 years, because I did not realize, but you cannot backport 6 or 7 years of work in 6 months, or you need more maintainers. And I'll talk about that later. That means more than 2,000 pull requests. So there were like 3 or 4 maintainers working on this. That's around 500 pull requests per maintainer. And it's not just writing, but also reviewing. So yeah, a lot of work. On end of October, we archived linuxbrew-core. That was with the minor release, actually, of Homebrew 3.30. And then when you run brew updates now, you'll get the migration will be done for you, and you will be migrated to Homebrew-core. What do the Linux users get out of this? Packages are delivered at the same time as macOS packages. There are less broken updates because the CI is running on Homebrew-core now. Also reduced bus factor and potential maintainer burnout, because you have seen the numbers. There were way too many core merges to do. And now more maintainer bandwidth, mainly for me. I have more time to work on nice new things and new features. What do the macOS users get out of this? And that's a nice side effect. Linux maintainers are actually fixing macOS packages, so that's nice. A few words on the Linux UI. So we built the packages or bottles in a Docker container. So we have a Docker container with a compiler and like the necessary stuff. It's nice because you can just throw it away and start again. It's easy to debug locally, so it's a nice tool. We had some constraints for running our Docker containers. From 2012 to 2020, I would say we had like no small budget, and we didn't really look for more money at that point. But we also, we wanted to use free CI time. One constraint was that we needed to upload bottle artifacts from fork pull requests, which means that you sort of have a credential issue. Anyone can open a pull request, so it needs to be like a 2-step process. And the uploading needs to be done in a second job. And build machines, of course, more RAM, more disk space. We need to transfer a lot of files over the cloud, and timeout limits are important for CI. The history in 2012, so I asked Sean Jackman, because I was not there. I was not working on Homebrew. They started with Docker Hub. So as they were building a Docker image, they also used Docker Hub to build packages. But they quickly stopped with that because there were no public logs. I think that was sort of one of the main reasons. And then in 2012, Travis and Circle CI started to grow, and the companies were created. So I think they quickly abandoned Travis, or like it was both were used. I'll talk about Circle CI in the next slides, because that's what we used for the most of the time. We gave a try for at Azure Pipelines in 2018, but we sort of never did to work, and maybe we did not invest enough time. I don't know. Because also we knew that in 2019 GitHub Actions were coming, so we went for that. Circle CI, the big limitation we had was like the RAM and the build timeouts. We also uploaded the package through Amazon, through a Lambda function, and there was a limit of 300 megabytes. So for some packages, it was not usable. I remember building 2 or 3 times LLVM a week, so it took 2 to 3 hours, and then we were uploading it over ADSL, which I was doing during the night to free some bandwidth for my family at home. So that were the good old times. Still, I want to thank Circle CI for the free CI time, because without it, this project would not have been possible. We knew that GitHub Actions were coming in 2019. You could use them, I think, from November 2019. And then beginning of 2020, we started really using it. And what we did is like a hybrid CI strategy where we used both GitHub Actions and one VM or self-hosted runner. So for the cost reduction, so for like 98% of the package builds, we just like need GitHub Actions, and you can spawn a lot of Docker containers, and it's free, it's fast. You don't need to maintain anything. And the 6 hours default timeout is fine. Still, for the like 2% of packages which remain, we needed self-hosted build machines. Some builds take more than 24 hours because we are testing the reverse dependencies. We also obviously need more disk space and RAM sometimes, and we still use the Docker container on the VM, which, I mean, we could use the VM directly, but it was just nice to use the Docker container. Looking at the financial part, as we reduce the cost by using GitHub Actions, we just need one Linux VM. At one point, I was unsure if we needed 2 or 3, but it looks like one is enough. Maybe there will be a second one for more testing at one point, or if we have more packages. Like the pricing is around $100 to $150 per month. We used Google Cloud because I felt it was easy to set up. Thank you to the sponsors which are paying for that. We looked at different strategies, grants, which are limited in time, and I feel nice if you want a lot of money, but like for like $150 per month, it's not the best fit. And then direct sponsoring is sometimes hard to find. I talked with a few cloud providers, but I was maybe not in contact with the right people. But as we have enough sponsors which directly give money to us, and thank you to them, we are just spending the money directly. So we can just choose the tools we want, and we are free to choose what we want and what we need. And we can also scale if needed. Last topic I want to talk about, this is a small picture I took from Mike Migrate's blog. So go and check the blog post. It's really nice. What Mike is saying is that you have a huge amount. If you have a huge amount of users, let's say we have 10,000 stars on GitHub, so we have probably more users than that. You have like less authors or contributors. I looked at the stats. There were 238 contributors to Homebrew last month on homebrew-core, and then you have like 33 maintainers working actively or less actively, it depends. And then at the end, you have maybe just 5 plus minus people working on ops and running the VMs and stuff like that. And that can be a bottleneck. And it's also one of the reasons why it took us so long to migrate linuxbrew-core and get rid of it, because we needed to set up the CI, and that took time. And it's not just about users, maintainers, and ops. I'm sort of improving the picture Mike has described, but you need also like the treasurer or financial manager. So we have a project leadership committee, and the SFC is doing their job on that side. But then you have like security experts and people writing documentation and doing stuff. And these people often do not come through your user base, but from somewhere else. And that's sort of the bottleneck for open source projects, which slow a lot of things down. Last slide. Small thing to celebrate. Homebrew on Linux will have 10 years next year. So maybe we'll throw some virtual party. I don't know. We need to find something. And then I put a picture of the real Homebrew CI setup with all the details. My name is Michka Popoff, and thanks for listening.
I love this last slide. Perfect image.
Yeah.
Let's see if there are any questions.
No questions? Everything clear?
Actually, your like entire setup with GitHub Actions and how everything kind of works reminds me a lot of Forge, which is one of the projects I work on quite a bit.
Yeah.
I'd be really curious to exchange more about that.
Yeah, of course. I mean, if you want to have a look at GitHub Action setup in homebrew-core, it's really interesting. There was a lot of energy and a lot of ideas to make it work, actually. And the hybrid CI setup, I did not go into detail, but basically we are using labels to switch between. If you put the slow CI label on the pull request, it will use the self-hosted runner, and else it will use like the default GitHub action.
And is the self-hosted runner up for the public? Like,
no. I mean, only the GitHub action can connect to it. So there are specific credentials and secrets for that. Obviously, like that machine is running like almost half of the time, half of the day, you know.
Yeah, I will take a look.
Yeah. I mean, if you have any questions, just ask.
There's one question coming in now from Tom. How easy was it actually to migrate to GitHub Actions?
I would say 2020 in January, really hard. It took us like 2 or 3 days of sort of hackathon at the FOSDEM with 2 or 3 maintainers. I would say now it's way more easy because you could just have a look at some templates, look at homebrew-core. There are a lot of things in there. At the beginning, there was also not like some things you needed to write some JavaScript to connect and have a look at the GitHub graph and make direct calls to the API. Nowadays, everything is in there. So I would say now it's really easy. The self-hosted runner part is hard because you need to connect to a VM, which you need to set up in the cloud. So you need to do ops, which means credential security and stuff.
Yeah.